So the objectives in terms of this lecture is to learn warehouse operations improvement through the application of best practice procedures and available material handling system for warehouse operations. So as you can see, the material that we learned before in terms of material handling is also important in terms of the design of our warehouse. So the renewed emphasis on the supply chain, and most of you should be, or all of you should be familiar with what is the supply chain. We discussed that in class. We spent one lecture in explaining what the supply chain is and how that affected the facilities planning. And customer satisfaction has increased the number and variety of value-added services in the warehouse. So right now, warehouse operations is not a place just to put the items until demand comes for those items. Now there's multiple operations in the last few years that are adding some extra services to the operations in a warehouse. So the extra services might include kitting, special packaging, now if you go to Amazon, you can tell them this is a present and they will put a note in your package and will send it to the person who was supposed to receive that present. Yes, sir. Is you're gonna receive an order from your supplier, and then you're gonna have some items that are related. Like if you have DVDs, you're gonna have multiple type of DVDs. You're gonna have multiple types of TVs, flat screens, and so on. So they're gonna go get the whole thing, and they're gonna start splitting those items according to those that are related. That's a good question. Yes, sir. Yeah. I apologize. It should be chapter 7 from your textbook. Yeah. It's lecture 11, but it's chapter 7. Thank you. And finally, or label application. In terms of the resources that you have in a warehouse, those include people, equipment, and space. Okay, so space can be your floor, or you can have also racks in which you can store items. So there are multiple ways in which you can add space to your facility. Unfortunately, such resources are often difficult to obtain and maintain. So the planning and management of today's warehousing operations are very challenging, because you have to make sure that you use especially the space optimally. People, you have also turnover of people coming in and out. Might not be familiar with the operations of your warehouse, so that also keep you on the loop of keeping people trained, how to use the equipment, how to move the items through your facility, and so on. In terms of the missions of warehouse, the warehouse plays a critical role in supporting a company's supply chain, success. Okay, so this is a very important element of your supply chain. And the mission of a warehouse is to efficiently effectively. Ship products in any configuration to the next step in the supply chain without damaging or altering the product's basic form. Okay, so that's also very important. You need to make sure that you send those items without compromising the status of the product. So our warehousing opportunities including order picking, and we're going to talk about order picking later, cross-docking, and we're going to talk about cross-docking in a few minutes, productivity, space utilization, and value added services. Allow the warehouse to process and ship orders more effectively. Okay, so in terms of operating the warehouse, we have different things that we need to accomplish. So first one is improving order picking operations. So today's supply chains requirements are driving warehouse operations to develop better order picking solutions. Those that are going to take you the minimum time. Those that are going to be allowing the order picker to actually provide the right order to the customer. So this involves putting the items on the right location so they can be easily found. Also, providing the person in charge of doing the picking of the items the right tools, and so on. So order picking is very important. Number two is utilizing cross-docking. The receiver typically requests that the cross-dock goods be sorted and pre-labeled. So for those of you who have not heard about this concept of cross-docking, what it does is you have a facility that is in charge of receiving all the items from different suppliers, and what they do is they don't keep the items in their facility. What they do is they just receive, sort, and ship. So they receive all the items, they order the items in the right order for the customer. So all the items are received here, they got the items, they put them together for the appropriate customer destination. Okay, so those are determined by those colors. What it means is that you're getting some of the items from each one of the suppliers, and you're putting them together to send them to your customer. So before cross-docking, you had suppliers sending items from their facility straight to the customer. But with cross-docking, you only have the supplier sending their items to the cross-docking facility. So there's a save in terms of trip. And so there's only one trip going from the supplier destination to the cross-docking destination. And from there, you're going to send the items or the orders to the appropriate customer. Yes. Kitting is it's a more elementary operation that is happening within the warehouse. This one we're talking about high-level things going to Walmart, for instance. So when you go eating, you're basically grouping the items to put them in the warehouse. Here you're looking at the orders that are requested by the customer and sending them to their location. Good question. So what I want you to see here is that you're saving some trips to your customer destination by putting that cross-docking facility in between. Number 3 is increasing productivity. And again, we're going back to optimizing, solving the optimization problem. You have the space, you know what the constraints are, and you want to find the optimal location for your items that will give you the best utilization of your space. So when you look at this statement, see maximize or minimize, what you're trying to do is to solve an optimization problem. You are not looking for one solution. You are trying to find out best solution for all the solutions that are available. So you want to maximize the effective use of space, equipment, and labor. Number 4, utilizing space. The old rule of thumb has always been that when a warehouse is more than 80% full, more space is needed. And why is that? You have to have some space for moving the items, you order the items. Let's say you have some items located in a far location in your warehouse. Now you need those items. You might need to move them into a different locations in your warehouse. So that's why that extra cushion space is important, so that gives you some freedom in terms of moving the items in your warehouse, and also allow you to plan for the future. So you start thinking about adding more space or finding different solutions to not fill your warehouse at any point. 5, increasing value-added services. So warehouses role has extended to include services to facilitate more efficient operations in receiving warehouse, and therefore that benefit the customer. And so this picture is coming from your textbook. It is trying to give you an idea or a perspective of all the things or all the opportunities that you can have in order to improve the operations of your warehouse by showing you all the entities that are involved on your warehouse operations. So the old definition of a warehouse as just a place to store, reconfigure, and short lead times has become more complex and technology driven. So instead of having just one warehouse from the manufacturer operation and going to the customer, now we can have consignation warehouse, people sending items or other manufacturers sending items to the same location, so we can have a combination of items to supply customers and so on. So there's, with information being available now, the use of technology, there are multiple things that can be considered to improve the operation of a warehouse. Okay, so in terms of the functions of or in the warehouse, there are many activities that occur as part of the process of getting material into and out of the warehouse. So here's an illustration also for the typical warehouse functions and flows. So you have a receiving area that direct put away to reserve, which means that you can put some items in your warehouse and keep them there until the demand for those items come, or you can also direct them to primary case picking. So where's the actual operation of putting together the orders happen. You can also send some of those items to cross-docking, so you can put them together in terms of orders for the customer, and so on. So there's some loops happening in this operation, but there's also some direct interaction between the receiving and the shipping of your customers. So in terms of the functions, first function is receiving. Which includes the orderly receipt of all materials coming into the warehouse, assuring that the quality and quantity of the materials are as ordered. So you need to make sure that you're receiving the right number and that all those units are in good shape. And disbursing materials to storage or to the organization functions that need them. Number 2 is inspection and quality control. And these are an extension of the receiving process and are done when suppliers are inconsistent in quality. This is something that you might find in industry. Sometimes the supplier that gives you the cheaper price is not the one that is going to provide you with the best quality. So you need to make sure that you compromise. You have the supplier that is sending you constantly units that are not good shape. You're going to be investing more money in your inspection and quality control. So at some point, that investment might break even with a customer supplier that might give you a better product. So those are things that you might consider when you're planning and selecting your suppliers. Number 3, repackaging. It's performing in a warehouse when products are received in bulk from a supplier and subsequently packaged simply in merchandisable quantities or in combinations with other parts to form kits or assortments. So I'm going back to the example of Amazon. They also provide a special type of packaging. I don't remember the name right now, but that's what they do. They put together some of the items that are related in terms of the functionality for the customer. Number 4, put away. It is the act of placing merchandise in storage. It includes material handling and placement. This is the basic operation of a warehouse, so you don't have to send that item to those items to your customer. So you're just gonna keep them in your warehouse until the demand for that item is received. Number 5 is storage. It is the physical containment of merchandise while it is waiting of the demand. Number 6, order picking. Which is the process of removing items from storage to meet a specified demand. And we talked about this in a few minutes ago. Number 7, sortation of batch picks into individual orders, and accumulation of distributed picks into orders must be done when an order has more than one item and the accumulation is not done as the picks are made. Then we have 3 more, which are packing and shipping. which is checking that the orders for completeness and also loading the trucks, cross-docking, which is inbound receipts from the receiving dock directly to the shipping dock, and then replenishing. So once you are done with the items, you need to go back and replenish your warehouse for the next customer. So primarily picking locations from reserved storage locations. So those are the functions in a warehouse. As you can see, there are multiple things that are happening within a warehouse, and our goal is to provide the best service to the customer, which could be the next supplier in the line, or it could be the direct customer, storage, or store, or a customer in particular. And we want to provide the best service to the customer. We want to be able to maximize the utilization of our space and also the utilization of our resources, which includes the personnel and the machines. In terms of receiving and shipping operations, the key decision in designing the receiving and shipping functions is whether to centralize the two functions. And that means that you're going to have the same door in your warehouse for shipping and receiving. And then we have several configurations that can be used for the design of your warehouse. And I'm going to explain the differences right now. So in this figure, the location of receiving and shipping depends on access to transportation facilities. Okay, so you're moving these items from your warehouse, so you need to make sure you plan. So you plan the location of your receiving and shipping based on the transportation means that you're going to use to move your items. So on the top we have a facility that mostly use highways or railroads to move the items. So you're going to make sure that you provide the right access for these transportation methods by locating those receiving and shipping place of your facility close to those to the highway or to the railroad. And if you pay attention to the railroad here in San Marcos going back to San Antonio, you'll see that there's some construction companies that have their locations very close to the railroad, so they can easily put the materials into the train and move them to the customer. So that's the type of allocation of those in terms of the location of the highway or railroad. And then the transportation facility on two adjacent sides of the building. So again, going back to the location of your, this case, the street. So here you have more flexibility because you have different access points, so you can plan based mostly on your design. What will be the best in terms of your design inside the warehouse? So you can put them into corners or side by side or across the facility. And then the third one is transportation facility on two opposite sides of the building, which is again same concept. Here you have less flexibility in terms of the streets that are available. You only have two streets that are parallel, so you might consider putting them on the same on opposite sides, one at the top and one at the bottom. So in general, the location of your receiving and shipping operation will be based on how are you going to be moving those items and the location of those transportation means. So the following principles serve as guidelines for streamlining receiving operations. They're intended to simplify the flow of materials through the receiving process, ensure the minimum work is required. So the first one, first option that you have is don't receive. So that's one option that you have as the manager of your warehouse. For some materials, the best receiving is no receiving anything. Often, drop shipping. Having the vendor ship the customer directly can save time and labor associated with receiving and shipping. So there will be cases in which that allocation of the items into your warehouse is not necessary. So you can skip that. And that will, for those cases, that will save you some money, space in terms of space and personal requirements. So you might find those cases also in practice. Number two is pre-receive. And this is the rationale for staging at the receiving dock. The most time and space intensive activity in the receiving function is often the need to hold the materials for location assignment, product identification, and so on. So performing some of the actions that you need to do in your warehouse, maybe in the receiving dock, will also save you time, space, and money in terms of your allocation of resources. Number three, cross-dock material. So since the ultimate objective of the receiving activity is to prepare material for shipment of order, the faster, most productive receiving process is cross-docking, okay, because you're going to be focusing only on that path. So the simplest kind of cross-docking activity is one in which an entire inbound load is sorted and then reloaded onto more outbound vehicles. Number four, complete all necessary steps for efficient load decomposition and movement at receiving. So this also relates to number two, because the most time we will ever have available to prepare a product for shipping is at receiving. And number five, sort inbound materials for efficient put away. And inbound materials can be sorted for put away by a warehouse zone and by location sequence. And then we have two more for the receiving principles. Number six is balance the use of resources at receiving by scheduling couriers and shifting time consuming receipts to off-peak hours. Depends also on the location of your warehouse. For instance, if you're trying to send some units to let's say New York City. You need to send a customer in order to the center of Manhattan, then you're not going to try to send that truck during peak hours. You have to find what will be the best schedule or time to send that truck within the operation hours of the customer warehouse. Um, Number 7, minimize or eliminate walking by flowing inbound material past workstations. This brings the stock to an order picking station equipped with the aids and information to perform the necessary task. So that's in terms of receiving. In terms of shipping, we have 6 principles. The first one is select cost and space effective handling units. So this in terms of how are you going to move the items within your warehouse? Are you going to put them into a container? What type of container and so on. So for loose cases, the options for unitizing loose cases include wood, pallets, plastic, metal, or nestable pallets. So you're basically putting the items in different type of material, but in a pallet to move them to your customer destination. For loose items, the options for unitizing loose items include totes, nestable or collapsible, and cardboard containers, so boxes. And most of the time we want to keep these boxes small so you can move the items more easily. And also going back to Amazon, sometimes even though you put an order of 7, 8 items, they will tell you they're going to split the orders. You're going to put together these 3 items, you're going to put together these 4 items, and they're going to send it to you on different packages. And that's also related to this point. Minimize the product damage, going back to keep the integrity of your product, try not to lose money by mishandling your items. Use storage racks to minimize floor space requirements for shipping stating. So we have some racks here. I'm sure you have seen these in you go to Sam's warehouse, you see these type of racks, and that help them to minimize space utilization by just putting those items in these storage racks. Route on-site drivers to the site to minimize paperwork and time. Again, with technology, these handheld devices and so on, you can save a lot of paperwork, scanners, and other type of technology can help you improve the operation of your warehouse. And going back to the same point, use small parcel shipping. That also helps you to have more flexibility in terms of moving those items within your warehouse and shipping them to your customer. Okay, so we discussed these shipping and storage principles. Now let's talk about storage operations. And in here, we're going to focus also on storage planning, and we're going to have some design tips and math related functions that we can use to improve the space of our storage in our warehouse. But before we get to that point, the objective of storage and warehousing functions is either to maximize resource utilization while satisfying customer requirements. And or
maximize customer satisfaction to a resource constraint. Okay, so now you start seeing why I ask you to go through these linear programming operation research lectures. These are concepts that are coming from operation research. So again, we're going back to maximize. Maximize finding the optimal one, the option that is going to give you the best performance in terms of using your resources and also satisfying your customer requirements. These two things are saying the same thing. This one is more in terms of the model itself, saying that you have a resource constraint. That could be your capacity in your warehouse, so you only have this area to work with, so you're going to try to find the best allocation of items based on that area that will maximize the satisfaction of your customer. Meaning that that can be measured in terms of the time that it takes for you to send that order to your customer. Maybe it's measured using the state of the items, so you don't have defects. That could be another way to measure the satisfaction of the customer, and so on. Okay, so we are trying to optimize or find the best way to fulfill these customer orders, and we're going to have some constraints in terms of resources. So storage and warehousing resources are, again, the space, the equipment, and the personnel that you have available for your operations. And in designing storage and warehousing system is desirable to maximize the space utilization, equipment utilization, labor also in terms of the material accessibility, and material protection. Okay, so I will recommend you to, well, not memorize, but at least remember this. So this is the goal of you while you're designing your warehouse. You're trying to maximize the utilization of your resources while satisfying the customer's requirement. So that's important. And in terms of planning the space for your warehouse, so you need to have a way to compute the amount of space that you're going to need for storage, the type of items that you usually produce in your facility. That's going to depend also on the demand. So how often are you sending those items to your customers? What is the amount of those units that you're sending to your customers? And so on. So you need to have a way to compute the space that you're going to need for your facility warehouse. So a chart can be used to facilitate these calculations of space requirements for storage and warehousing. So here's an example of a storage analysis chart. So we have the description of the items that we usually have or produce in our facility. In this case, for this company called GDS. So we have the description of those items, and then the type of storage that you use to put those items. The capacity um, per item or per box you have for each one of the items. So in this case, we have 50 pieces per bundle. The size, the weight, the maximum that you will have in your warehouse at any time. So in that case, is 14. The average 5, and then you are planning for not the maximum, but more than the average. So that's your plan amount, the plan that you want to have in your warehouse. Um, the method that you're going to use to move and to store those items, the specs, the area that those items are going to use, and the height that those items are going to require from your warehouse. So using all this information, then you can estimate the space that you might need for your warehouse. So there's nothing complex, or this is very straightforward process. You just have to have a good estimate of your demand and the space that each item is going to occupy in your warehouse. So there are two major material storage philosophies. The first one is called fixed or assigned location storage, and the second one is random or floating location storage. So again, this is also very important. If you can put a star here, these are the two material storage philosophies. I'm going to explain the difference between the two. So in first one, in fixed location storage, each individual stock keeping unit, that's SKU, and you will see this in practice a lot. You want to be familiar with that terminology, stock keeping unit, meaning the item that you're going to store. It's stored in a specific location, and no other SKU may be stored there, even though the location may be empty. So you're going to reserve that space for that type of item, and you're going to only put that item in that location in your warehouse. With random location storage, any SKU may be assigned to any available storage location. So if you have a space available and you have some items coming in, you can assign those to that empty space. An SKU stored in a location A on 1 month might be stored in location B the following month, and different SKU stored in location A. Meaning that you don't have the space assigned to that type of item. You're going to allocate them according to the space availability that you have at that time. So in terms of the amount of space planned for an SKU is directly related to the method of assigning space. And what would you expect? If you're using, for which of the two options would you expect to have more space you say? Yes, that's correct. Exactly. So we're going to show that also in terms of the problem, but that's correct. So if you are using
assigning specific area for specific type of product, then you might end up having a necessity for more space or a need for more space because of that requirement. But if you have randomized assignment, then you know that you're going to assign the products to any space that is available. The requirements in terms of space are less. So if fixed location storage is used, then a given SKU must be assigned sufficient space to store the maximum amount that will ever be on hand. For location storage, the quantity of items on hand at any time will be the average amount of each SKU. So for fixed location storage, sufficient space to store the maximum amount that will ever be your hand, so that will be your design requirement. And for random location storage, the quantity of items on hand at any time will be the average amount of each SKU. So when the inventory level of one item is above average, another item will likely be below average, because that's what's going to happen. The sum of the two items will be close to the average. And if a large safety stock of SKUs is maintained, then the quantity of items on hand at any time will be the safety stocks plus 1/2 the maximum replenishment quantity of each individual SKU. So this we are going to use as a design requirement for our next problem, our first example. And that's the last thing we're going to do today. Okay, so the first example says that we need to determine the storage space requirement in number of loads. And the ABC manufacturing firm, the average daily withdrawal rate for product A is 20 cartons per day. We have a safety stock in 5 days, and the order lead time is 10 days. And the order quantity is 45 days. And the question is, what are the maximum and average quantities of load to be stored? Okay, so we have some design requirements, and we want to estimate what will be the maximum and average quantities of unit loads. So again, for the assigned location, we need the maximum. For the randomized, we need the average. So we are going to use the information in terms of, so this is the question, average quantities to maximum. So for that, we need to compute the reorder point, which is equal to the safety stock in days times the demand per day plus the lead time Anybody familiar with what the lead time is? So lead time is the amount of time that you have to, from the order point to deliver the item to your customer. So you have 5 days, that means that you have to fulfill that order in 5 days. And times the demand day. So for this problem, the reorder point is 5 days times 20 cartons per day plus 10 days times 20 cartons per day. So the reorder point for this is 300. And now we're going to compute what's the maximum quantity to be stored. So the maximum equals the safety stock plus the ordered quantity. So the safety stock is here. We computed that. It's 5 times 20. So this is 100 plus the ordered quantity, which is 45 days times 20 cartons per day. And that's equal to 1,000. And the average quantity to be stored equals 1/2 of the order quantity plus the safety stock so this is 1/2 45 days times 20 cartons day plus 100, and that's 550 cartons.
Okay, so we compute the maximum and the average quantity of units to be stored.
And using these numbers, we can
Use this information to start planning for our allocation of items in terms of two philosophies for warehouse. So I'm going to stop here today, and we're going to continue on Wednesday. That's it. So where's the attendance?
And one more thing, I have your homework 6 here. So if you want to keep your graded homework, it is here.